Wherever large quantities of cooling and processed water are used in power stations and industrial plants, fouling problems occur. In this power station, the plate heat exchangers have to be cleaned regularly due to large quantities of fibrous material and mussels being carried in the cooling water. Consequently, the entrained debris has to be repeatedly removed in this labor-intensive and expensive manner, often during emergency shutdown. And that's not the end of it. The mussel larvae, which are far more difficult to remove, constitute an even more serious problem. Microscopically small at first, the larvae enter the circuit through the pre-screening filters and become attached throughout the cooling water system. Nourished by the supply of food in the cooling water, the larvae grow quickly and block the condenser tubes or the plates of the heat exchangers. In cooling tower power stations, we come across quite specific types of debris, such as bits of concrete, fragments of internal parts, dust from the air, alkaline scaling, and, depending on the time of year, grass or leaves. Algae and fibers are particularly difficult to remove and cause corrosion, erosion within the system. The extent of all this contamination is clearly demonstrated by this cooling tower pond. Result, unplanned plant shutdown. Clean water is also required in industry. In steelworks, for example, the fine nozzles of the scale washers have to be protected from fouling. Here too, the water has to meet stringent criteria to prevent scale deposits being rolled in and affecting the quality of the sheet steel. There's only one way to meet the demand for clean cooling and process water, and that's with filters. Outstanding results have been achieved with the Taprogge Pr-Bw range of filters for removing coarse debris. Debris particles in the 50 to 1000 micron range still present considerable problems. Let's take this area, or in this area, or in this area, or in this area. Filter media such as perforated steel sheet or wire screens quickly become blocked. Backwashing does not clean them properly, since individual particles of sand become lodged in the mesh. Basically, the same problems occur with wedge wire screens. High-volume backwashing of the filter screen will not prevent residual fouling, leading to permanent contamination. Even the development of breathing filter cartridges has not resulted in any significant improvement. Here too, we note unsatisfactory debris levels after backwashing. The result of our brief comparison. All systems used so far in fine filtration cause irreversible contamination and fouling. It's not only the high backwash water volumes and operating pressure drop required by these filtering systems which makes them costly and uneconomical. They also have to be exchanged and intercepted, and to accept, 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 and to accept the cleaning of expensive clean plants, or to treat the water chemically. Cooling water, drink, cooling water, drink, cooling water, drink, cooling water. Set itself the task of developing confined filtration. Many years of intense successful. The heart of this new fine filtration filter range from Taprogge is the active filter element. Filter cartridges for every application are created simply by fitting the various elements together. This experimental rig illustrates the advantages of the active filter elements quite clearly. The filter elements become fouled very slowly. and they are cleaned completely by backwashing. Let's look at that once again. When assembled, the filter elements form flow channels and filter gaps. All particles larger than the width of the gap are retained in the filter cartridge during the filtration process. When a preset level of filter fouling is reached, the backwash process is initiated. Reverse flow releases the pressure on the lips of the filter elements, causing them to spring back, enabling even those particles that have become firmly lodged to be removed. In the filtration process, even at minimal flow, the lips of the filter element return to their original position along the spacers to form a filter gap once again. The development of the active filter elements enables Taprogge to meet all demands for fine filtration. Through this finely graded filter range from 50 to 1000 microns, all types of debris can be combated effectively. Combining these filter cartridges with tried and trusted Taprogge technology produced the Pr-Bw 100FC. The Pr-Bw 100FC fine filter consists of a hemispherical inlet housing with an outlet housing which can be either hemispherical or, as in this case, cylindrical, the partition plate with sliding segment, the backwash rotor with sprung flushing shoe, the geared motor with bearing, the differential pressure measurement system, the backwash valve with positioning drive, and the control panel. The polluted water enters the fine filter through the inlet pipe and flows through the filter cartridges from the inside to the outside. It's here that the particles of debris are retained. The purified water leaves the filter through the outlet nozzles. When a preset level of fouling is reached, the filter is automatically backwashed. The entire filtration process is fully automatic. The pressure lines of the differential pressure measuring system are connected across the clean and dirty side of the filter elements. The pressure differential across the filter element increases with the fouling. When a preset limit value is reached, the rotor begins to move and the valve of the backwash pipe opens. The flushing shoe, with its automatic spring adjustment, covers one filter cartridge at a time. The backwash water only flows through the filter cartridge from the outside to the inside, due to the pressure difference between the system and the end of the backwash pipe. The debris particles are flushed from the filter via the backwash pipe. The backwash process is stopped when the differential pressure across the filter elements reduces to the value set for a clean filter. Fine filters from Taprogge are designed for each specific application. The results of extensive laboratory testing of a wide range of filters form the basis of a computer-aided expert system. By collating the four main filter design factors, size of construction, pressure loss, backwash volume, and debris capacity, it's possible to design the optimum filter for each application. All customers know their technical and economic operating priorities. Once the requirements have been identified, Taprogge will design a custom-made filter to suit the particular application. Diameters from 100 to 1200 millimeters, a range of inlet housings, single or double bank installation, outlet housing in hemispherical or cylindrical design can be implemented without problem due to the Taprogge modular system. This enables Taprogge filters to be installed at any point in the cooling water system. The Taprogge Pr-Bw 100FC is the solution for all fine filtration problems. Taprogge fine filters are used for purifying cooling and process water in auxiliary cleaning systems, in front of plate or tubular heat exchangers, in pump bearing, cooling and lubrication systems, for side stream filtration in cooling tower systems, for fire protection systems, and for treated spray water. This is the reason why Taprogge filtration systems are found in steelworks, chemical plants, and of course in power stations. At this power station, 3 Taprogge fine filters have been installed in the auxiliary cooling system. Fitted with filter cartridges with a gap width of 300 microns, they reliably filter algae and sludge from the cooling tower water supply. Plant availability has significantly increased following the installation of these Taprogge fine filters. Taprogge is the international market leader in the field of cooling water system optimization. With more than 1,700 filters installed worldwide, Taprogge has outstanding experience of all filtration problems. This makes us confident that we can offer the best engineering solution to your filtration problems.